Let's start recording now. Hello, everyone. Welcome to another beautiful day here in remote quarantine land, where we all get to talk to each other through a screen. It is wonderful, and we get to talk about web development. So today we're going to talk more about JavaScript and introduce a little bit more about taking it into an actual page. And so a couple things I'm going to get to before that is going to address quiz 1, which is going out today. I'm going to quickly recap the video that I released last night. I know it was late, it was short, we didn't announce it everywhere, and so I wanted to make sure more people got to see that content. And then we'll go into adding JavaScript to a web page. So first off, quiz 1, we're going to release it after lecture, probably around 3 p.m. We'll try to do it on the dot so that we can then close it at the same time exactly 24 hours later, which will be your window for completing the quiz. And a few notes on that. We're only going to be grading the first so many words. We don't want to be reading long essays. We don't want to have you writing long essays. We just want a short, concise answer for each of the questions. And so while many of these questions could be answered much longer, we're only going to look at approximately a couple sentences worth of words. It varies by question depending on whether it's a multi-part or a single part or a longer answer versus a shorter answer. It'll be specified in the question. Generally speaking, we're not going to answer or address questions publicly about the quiz. If you have questions about them, ask them either in office hours after lecture or in a private question on Ed. And speaking of Ed, just like CP1 and in future assignments, we're not going to be answering any questions about the quiz the 1 hour before the deadline. So if you have questions, if questions come up, or if you're just taking the quiz and expect to maybe have questions, do it before 2 p.m., before the 1 hour before the deadline. Otherwise, we're not going to address questions then. And naturally, no late submissions will be accepted on the quiz. So that's that. It will cover any content that we've talked about over the last 2 weeks, up to and including today, although given asynchronous nature of things, things done today will be a little bit on the lighter side. But otherwise, everything from the last 2 weeks is fair game.
Just quickly, Fitz.
Yep.
I just want to mention that this will be available as an online assessment in Gradescope. So it will open at 3 via Gradescope, and then it will close at exactly 3 p.m. tomorrow.
Cool. And are we going to post links to that in places so people can get direct link? Yep. Okay. Awesome. So about this DOM thing, I'm going to drop over to Pull Everywhere and open up this Pull Everywhere. Question for you all is that we've mentioned this DOM thing a couple times. I talked about it a little bit in the video last night, but just kind of getting a poll from the room. What is it, and where does it come from? I'll give a minute or two. There's a lot of words here, so I'll wait for a little bit while people read and select an answer. Looks like we've got 196 people on, so I'll wait for close to that-ish for number of results. right, that's a reasonable response rate. So I'm going to go ahead and show responses. So I took the suggestion, I don't remember who it was, to turn off show responses while we were answering questions. And so it is interesting that we've now split between these two different answers. One being that it's kind of a way of thinking about websites like objects versus it's a representation of a website created by the browser when it receives an HTML page. So I gave these two different answers on purpose. They're very similar. They're overlapping in concept in some ways. And that, yes, the document object model is kind of thinking about websites as objects, but it's a very specific kind of object, which is created by the browser. So both of these answers are somewhat correct. The second one is a little bit more correct, but both are close. And we'll see the object-oriented programming aspect of this come up while we're working with our JavaScript. And so just to quickly recap the concepts that I talked about last night. The browser goes through a life cycle of different things when it's trying to load a website. The first thing it needs to do is it needs to talk to the internet and actually go and get the page. It needs to parse the website to actually get some information about what it is and build that document object model. And it does the same thing again with styles. And then finally, at the very end, can it show the page? And then at that point, it starts waiting for events from either the user or JavaScript. And well, that's going to be our transition into the rest of adding JavaScript to a page. So during the fetch page stage, it does a few different things. The first thing it has to do is translate from our DNS name, like google.com, into an IP address where it can actually talk to a server on the internet. And then it does what we call an HTTP GET request. And this is something that's going to come up in the future when we are writing our own backends and our own server-side applications, where we're going to have a difference between GET and other things. But for an initial web page request, it does a GET where we're just asking for an index.html, for example. And it specifies a couple of other bits of information, and we call those things the request headers. This allows us to say things like, I'm this user, or I'm requesting things from this specific host. And because a web server might be able to host multiple websites, and we're not going to touch on that, but all of this information is sent over the internet to the server via TCP/IP rules. And so this is network communication. When the website receives it, returns the response back, we get a HTTP status code, for example, like 200 OK. And all of this information is in the response contained within response headers. So the mirror image of the request headers. So the browser at this point has gotten to 200 OK, and it goes through the HTML line by line to build up a document object model. And so it goes through step by step and builds up this tree of nodes that are contained within the HTML. And this tree itself is our document object model. There's lots of information here. But what I didn't quite cover last night was that when it hits certain kinds of tags and certain kinds of information, it does some things a little bit differently. For example, here we've started going through the head tag, and we've built the title node, we've built the meta node, and we've hit this link node. And the browser sees that link and it pauses. It says, okay, this link tag is specifying another resource. It's another kind of thing that I need. And so it issues another HTTP request. And so we do a get, we try to get that styles.css file. If I go back to this HTML, the name of it is styles.css. And so this link is specifying that we want that particular style sheet reference. Real quickly, I'll address that. Internally to browsers, the tree is it's not a binary tree. Binary does imply 2 children only. So the internal tree representation is dependent on whatever browser implementation they want to use. All kinds of different options exist for that. It's not necessarily important for us. We do know that JavaScript has quick access to everything in the tree, depending on whatever data structure it's using. So once we get that CSS, that link tag has specified that it's a style sheet. And so what the browser does is says, okay, I've gotten the style sheet. It's defining a bunch of styles and the way things look and where things are on the page. At some point, that's going to be important for whatever is in the rest of the DOM tree. And so I'm going to, as the browser, schedule an event in the future to say, I need to restyle the page. I need to apply whatever CSS rules are in this to the DOM. Okay, so we've handled that. We've scheduled this future event for restyling things. And we go back and we go back to building up the document object model, this tree. And now we've get this script tag. And the script tag is also special. We've got this attribute, this src attribute, which is short for source. And it's the same idea. We say, great, that source is now in another location. So I'm going to have to do another HTTP GET request to get that script.js file. And I know it's a script, and I know that it's JavaScript, not Java. And I'm going to parse that. I'm going to try to understand it and make sure that it's valid, executable JavaScript. So I'm going to parse it. I'm going to compile it. And then the browser actually at that point immediately runs the code. And so this is something that's not quite obvious, where at the point the script tag appears, the JavaScript is run. So if you remember from Wednesday, when we had that, I'll want this back up in the future. So this is more or less where we ended on Wednesday, where in this console, in the console view, we had the cannot read property AddEventListener of null. And so that's happening here with this one because this script tag is run immediately, but the DOM is missing a bunch of elements. A bunch of the nodes that we expect to see, everything in this body is not part of the DOM yet. So to answer your question, Aaron, this script.js, for example, in my buttons example, if I go and look at the source, oh my gosh, it's so big. I'm here trying to reference an element that is ID button, and it doesn't exist yet. And so that's where we're getting this particular error. We'll get there. So question is, so why don't we put the script at the bottom of the HTML page? You will see that in some ways, but it ends up being not really semantically right, because the head tag is the tag that contains extra information about the page. And the body tag is the thing that contains everything that appears underneath the address bar in the browser. So the body is the content of the entire page. But the JavaScript for it, it's kind of this content for the page. It's kind of not. It's more providing extra behavior for the page, and maybe applies to specific bits of content. And so semantically, from an idea of what does it mean to include a script tag, we want to have that in the head, because that's just information about the page. Okay, so after it's parsed the script tag and compiled that JavaScript, run that JavaScript, it then continues and finishes creating the entire DOM. And every node in the tree has its children, the name of the element, the attributes and their values, any of the content that might be in there. And we'll get there. And then it also goes back and applies the same thing for styles. But between having the DOM and applying and checking the styles, we as the browser issue something called the DOM content loaded event. And so this is getting to your question, Aaron, here about the browser has just in a notification that it issues to anyone who cares to listen to it, that the DOM has finished loading. And none of the styles have been loaded yet. And so at that point, after we fire that event, the browser now goes through and computes all of the particular styles and maps it over to the DOM tree. But we have that DOM content loaded event, which is really, really useful. Once it has the styles, because remember that some of the styles can change where things appear on the page and if they appear at all. And so the browser, after it has the styles, fires another event to tell any listeners that we are now actually ready to draw the page. We are at the point of being able to paint pixels onto the screen. And it fires what's called a load event. And at that point, it combines everything into something which is the combination of things to show actually on the screen. Okay, I'm going to pause for questions for a moment before we continue. Jeremy has a question of, so does the DOM content loaded event come before the CSS? It does, yes. We're not going to use that event necessarily, but it's something to be aware of, that there's this series of events that happen up to the point before the page is completely done loading and ready to be shown to the user. Ilya asks, do we use the load event for our JavaScript? Yes, we will see that momentarily. So hold on to that thought. So Kevin is asking, when does the JavaScript run in relation to the DOM tree loading? So the JavaScript runs wherever that script tag appears in the DOM. So in this particular example, the JavaScript runs right before the body starts loading. So right at the very end of when the head is read. And that's in part because the JavaScript could potentially affect what DOM things exist, what HTML is written. It could add some event listeners, and it could just do a bunch of things that might affect the rest of the DOM loading. And so the browser tries to read and interpret that beforehand. With the CSS file, all it does is look at it to say it needs to use it later. Kind of what it and the reason it does that is because so we go back to here. At this point, it's just kind of like the JavaScript, where we don't yet have the rest of the document object model. We don't have the rest of the HTML yet. So if your CSS has a particular rule saying, I want these styles to be applied to this ID or to that set of classes, then it doesn't know that it exists yet. So it's saying, okay, I've interpreted the CSS. I kind of know, what rules need to go where to a certain extent, but we're actually going to apply them later once we have the rest of the DOM. Next, Jeremy, is it normal to have the script before? Yes, it is. It is standard practice to have the script that you want to be included in the page to be right up front, and we'll address how to momentarily how to address the fact that it runs before everything else gets interpreted. James asks, if we place the script tag earlier in the header and don't include any event listeners, would it run earlier than if you had it at the end of the header? Yes, technically, it would run momentarily earlier, but you're not likely to see any noticeable difference in there, unless you had something like the JavaScript was introducing more CSS to load, which is very uncommon. We don't typically see that. But for the most part, and for everything that we're going to see in this course, you're not going to notice a difference if you have the script earlier in the head versus later. It does make a difference, but it's not noticeable. Okay, so I'm going to go forward. Couple of the questions have led me to answer, hold on and wait and see what we do. And so let's actually get into that. So here I have the code that I ended with last night, where we have a header, a button, an image within a Flex container. And the thing that's interesting about this particular code is that we have this button.js, and it doesn't work because, as we just saw, that script is loaded and run at the point where none of the rest of the DOM exists. So a couple of things that we want to try to do. Go and open my button.js. The first thing that we have here is, well, the only thing we have here is that the code is trying to add this event listener to the button. It's the only thing we want to do, and we want to make sure that the button actually exists when we try to do it. It's and it doesn't do anything other than set up some future thing that could or could not happen. And so I'm going to put all of this code into its own function. I'm going to call it init because, again, all we're trying to do is some initialization to set up some event listeners for the future. And now when I save and run this, I'll go back to the console, I don't have any errors because all I've done now is define a couple of functions that I can use in the future. So I could here in the console run my init function, and I should probably actually bring my button back so I can see it. We'll run init again, and then I can click on my button, and sure enough, that works. If I refresh the page again, I've not run the init function, and so I click on the button, nothing happens. So again, all we're doing so far is we have the functions defined, but we haven't run them. And so what I'm going to do next is somewhat referenced earlier, where we can add an event listener to listen for the load event. We check back to the slides. This load event is the thing that that lets us know that the browser is ready to draw things. And what I want to do, just like if I were typing it manually into the console, is run this init function. So just like from our button, we have the add event listener, but we have to add the event listener to something. And so this is kind of where that object-oriented programming aspect of things comes in. And just like how we have a document that references our entire HTML document, we also have a window which represents the browser. So with the window.addEventListener, we can say, run the function named init at the point that the load event is issued. I'm going to save that, refresh this. No errors, that's good. And then I click on the button, and sure enough, we get our hello worlds. I can refresh again, and we still get it. So now we have our window running the init function as soon as the DOM and all the styles are applied and ready to be drawn. Our init function adds an event listener to the button, and then we can run it. There's a question in the chat about, in the reading, it talked about OnClick rather than AddEventListener. Difference between the two is pretty subtle. And we can actually go and look at the documentation for OnClick. The thing that's special about OnClick is that it only applies to certain things. Everything in the DOM tree can have an event listener, but only certain things can have an OnClick. And so you might notice here, if I search for button, there is no OnClick attribute for a button. And so OnClick is, actually, this is the SVG reference, not. Look at this one. Okay, so this one does have an OnClick. What I suspect, I don't know for certain, but what I suspect is that OnClick underneath the covers, behind the scenes, is using some variant of AddEventListener. We use AddEventListener as kind of the generic way that it will always be able to be run. So they can have the same effect. We are preferring AddEventListener.
fits.
Yep, go.
Just want to add one more thing. I believe if you use OnClick, you can actually only add one event listener. Whereas with AddEventListener, you can multiple. I think you might have just said that, but that's really important. And I think if you use OnClick, it's difficult to remove add listeners as well, event listeners.
Yeah, that's a good point. So a lot of those changes or qualities about OnClick come from the fact that OnClick is an attribute on the element rather than part of the JavaScript execution. And so, being an attribute, it's just there, and you have to do some fancy things to try to remove or edit it, as Andrew said. Okay. Go back to here. And so here in my button.js, I have we're running our init after the window has finished loading, and we're adding some event listeners. And these couple of functions named init and handle click are there's a reason I'm able to run init, for example, right here, just in the console, in that this function is now defined as a global variable and a global function. And it's a fairly common name in it. We could have other bits of code that have a function named init. We could have the browser maybe having a function named init. And it's just accessible to anything on this particular web page. But like in other programming classes where we don't really like global variables for a variety of, we want to maintain access control, we want to maintain privacy on those variables, we want to make sure they're not going to collide with things that they don't need to collide with. We also have the same principles here in JavaScript, where we don't want to have these global variables and global functions. But as you might imagine, and as you might be aware, when we write our behavior in our JavaScript, we start to end up with a lot of different functions. And we don't want to have all of them potentially colliding and try to figure out names for different things that are going to make sure they don't collide. And so what we do is introduce something called the module pattern. What this module pattern does is allow us to encapsulate all of the things that we care about into a private thing that only it and the things within it can access. And so the way we do that is we're first going to define an anonymous function. An anonymous function only means that this is a function that doesn't have a name. It's an unnamed function. We're going to take everything from our code and stick it within this anonymous function. So now we're almost there. We have this anonymous function that contains the things that we want to have as part of our page. And you'll note this is kind of an interesting feature in JavaScript, the language, where in other languages, functions can only have statements that do things, declare variables, have loops, have if statements. Here, a function is kind of like an object. In fact, it is an object. And so we now have a object that has some functions within it, some methods. Now, if I just leave it at this and I run it, my click is not working, right? So something is not quite right here because this anonymous function has declared these things, but none of the things within it have run. So what we can do is add some parentheses down here. At the bottom here, I've added 2 parentheses right before the semicolon. And this has indicated that this is what's called a self-executing anonymous function, where it's a function with no name and we are running it immediately. So now we're going to get the same effect as what we had before introducing this thing, in that when I click the button, I get my hello world and it works just fine. And then I can go through here and I'm going to reorder things just for the sake of it, so that my init is up top. And just for the fun of it, I'm going to show what was discussed in the chat, where we can potentially have multiple event handlers on a button. Both of them will be run every time that I click this. What is the point of using this anonymous function as opposed to regular functions? In this particular case, the anonymous function is used so that we don't necessarily care what it's named in this case. We just care that it's scoped so that things within it are private and not global. And so we don't care what name of it is. If you look it up on the internet, you will see a variant on this which does name it. But for our purposes here and in this class, we don't care what the name is. We just care that all of these functions are private and not accessible. You can, in fact, have multiple anonymous functions. I could have defined a function here within the AddEventListener instead of having it be a named function. We don't like this behavior because for readability and style purposes, it's preferred to have any of your functions named. In this case, it's sort of okay because we only have a single line within that function, but we'd prefer it to have it be named. Why is the outside anonymous function wrapped in those? A couple questions there. So I'll pause. I don't necessarily know the answer, and so I'd be curious to see if one of our TAs knows the answer for what particular JavaScript feature is requiring us to have these parentheses before and around it. I'm actually not sure.
Did you verify that it doesn't work without them? I'm pretty sure it doesn't, but just to see.
Function statements require a function name. No, it does not work without them. So we'll come back to you on why those are required. We'll have to look up the exact syntax rule for why that's the case. So I'm going to talk a little bit about why we're naming these and putting them in here. And I'm taking the time on this because it's good to see this JavaScript in action, and we'll get more practice with it and talking about things like callbacks and more JavaScript features next week. And I know we have a quiz coming up, so that's I'm trying not to introduce too much new stuff here. But that said, when there was a question in the chat about why couldn't we just do this, where we have this, instead of having this named function where it's going out to this function and calling it, why don't we just put the console.log in there? So I'll refresh. You see that the hello world actually happens immediately. So this is a difference between the method being, the function being called immediately versus providing what we call a callback, where the function can be called at some future time. And so what's happening here is when we do this myButton.addEventListener, that console log is happening exactly right there. And yes, because of the parentheses here, we are effectively saying that there is a log function or a log method that is being passed the parameter hello world. And so that console.log function is being called immediately at the point line 6 is interpreted. And so if we want that to happen in the future, we have to give it a reference to a function rather than calling a function immediately. The AddEventListener does not return anything. We can run it in the console. Oops, I don't have that defined here. And so with this bit of code, we'll see that the event listener does not return anything. All it's doing is taking that reference to a function and adding it to a list of potential things to do in the future. And once it does that, it's done, and it doesn't have to tell us anything back. Null and undefined are not the same thing. It's tricky. It's one of the things that catches people a lot in JavaScript. Undefined is basically saying that whatever thing you just tried to reference or look at doesn't exist. Null, meanwhile, says that the thing does exist, it just doesn't have a value. And so it's kind of a subtle thing, but yes, there is a difference. Oops. All right, so we'll back that out. Okay, and so that has actually covered everything that I wanted to cover today, which brings us a couple minutes early. And so if there's specific things that people have questions about or want to see in JavaScript right now, I'm happy to go through that. In particular, there's some interesting things with typing that we could talk about. But in terms of core content that we wanted to cover, that's for today. So Andrew, do you have a thought?
Yeah, I just wanted to ask really quickly. I appreciate other students helping to answer student questions in the chat. If possible, though, could we leave answering questions to the TAs? It just makes the questions easier to manage and find for the TAs and for other students as well.
Yeah, for sure. And to add to that, they're kind of repeating some things that I've said in past lectures on. There's lots of technically correct information on the internet about doing web development. Web development has been around for 50 years almost, and so there's tons of resources about it. Um, but it also means that some of it is very, very out of date and very, very not according to best practices, not according to best styles, and more importantly, not according to um, our courses, styles, and practices. Um, our TAs and instructors are very familiar with what those are. And so if a quiz question comes up or a homework assignment spec item comes up that requests a certain particular feature or way of doing things, we are going to assess and we are going to grade on what our courses defined best practices are. And so if you see an answer in the chat from just from someone, you don't necessarily process who it's from. It might be technically correct, but it might not be assessed correctly for our course. So that's another reason why we'd really prefer that questions are answered by TAs. Um, okay, a couple questions in the chat that I want to talk about. Example of something we want before the DOM would be things like having the CSS link here loaded as early as possible, so that the browser knows before it styles anything, before it shows anything, what needs to appear and when. Um, and a good practice for that is because if things change on the user after things are displayed, you can get some weird effects, like buttons moving around or images moving and moving buttons to a different location, and that's not necessarily great. It's that if you've ever seen a website taking a long time to load and things kind of like pop in and out and they're moving around all over the place, it's because they didn't necessarily order things in a way that's most efficient for the browser to figure things out. Yeah, so Justin's question on what's making the anonymous function private. Other languages have private public keywords. This is partially because JavaScript originally wasn't really object oriented, and so it kind of had to add it in. And so that's we don't have the private public keywords at all. And it's the curly brace syntax is the main thing that adds the scoping and the privateness to it. But it's kind of not really private. You can still access it by going through the anonymous function, but because the anonymous function is anonymous and unnamed, you don't have a handle on it. You don't have a reference to this thing, and so it practically becomes private because there's no reference to do the dot syntax to get access to things. Um, Couple other questions, but we are officially over time. So before answering more questions, I'm going to just we'll close it out and say thank you very much, everyone, for being here again and being with me. And the recording will be posted as soon as it gets processed. And I hope everyone has a good weekend. As usual, I will stay on for a few minutes answering any questions, but you can consider us for lecture done today. Thanks, everyone.